All right, so let's do a couple of just straight out coefficient of friction, force of friction problems. So it says use the following information to solve. They tell you that the coefficient of friction for rubber and dry asphalt is 0.9, and the coefficient of friction for rubber and wet asphalt is 0.45. You have a 1,500 kilogram car heading west, and it slams on its brakes. So let's just go ahead and we'll make it big here. 1,500 kilograms, and it's going west, and it slams on its brakes. So I'm going to shortcut some of these since we've done examples in the previous ones. If I'm 1,500 kilograms, and I take that times 10 meters per second squared, that means I'm going to have a force of weight equal to 15,000 newtons. And I'm going to have a normal force, because this is a flat surface, equal to that, of 15,000 newtons. All right, my car is heading west, so let's just make sure that left is west and east is right. That means I'm going to have some force of friction working backwards if it's going to the west. All right, so then the question is, what would the frictional force be to stop the car on a sunny day? Well, we can assume a sunny day is going to have dry asphalt. So my force of friction is equal to mu times my normal force. We can just substitute in our numbers. On a dry day, coefficient of friction, or mu, is 0.9 times my normal force, 15,000 newtons. Okay, and 0.9 times 15,000 gives me 13,500. Okay. And we'll do the second part here. On a rainy day, our coefficient of friction is going to be less. Exact same process, but we can predict that that force of friction should be less available to stop your car. That's only 0.45 on a rainy day. That normal force is still 15,000 newtons. So 0.45 times 15,000 is 6,750. All right, so that rainy pavement doesn't have as high of coefficient of friction, which means there's going to be less force available to stop your car, which means it's going to take a lot longer to stop.